Hello and welcome to another video. In this video we're going to be working on maximum nesting depth of the parentheses. And honestly the hardest part of this question is just reading this whole situation. But essentially what they tell you is you're just looking for the maximum depth of a given set of parentheses, and the parentheses are always valid, so you don't have to check for like matching or anything. So if we actually look at these examples, it's pretty clear. So here there are no parentheses, so the depth is 0. Here there's one parenthesis, so the depth is 1. And here the maximum depth is 2 because there's an inner parenthesis and an outer parenthesis. And then so if we take a look at like this example, essentially this whole thing is in parentheses, and then this thing is in parentheses, and this is in parentheses. So the level is 3. So you pretty much need to try to figure out like what's an efficient way of doing it. And here it's also 3. But if I was to like put a nested one, then it would be 4 and so on. So essentially it's a pretty easy problem. Basically, if you think about just like how do parentheses work, like let's just say we have like a 1. So this would be like a level of 1. Then this would be a level of 2, level of 3, and so on and so on. So it's pretty straightforward. All we have to do is every time there's an open parenthesis, we add a level. And every time there's a closed parenthesis, we subtract a level. So for example, for this, the thing in here would be at level 1, the thing in here would be at level 0, the thing in here would be at level 1. And if we add somewhere, like let's say we add one here, then this would be at level 2 and so on. So essentially we can just keep track of like what parenthesis we're on, and then we just have to figure out like what's the maximum number of open parentheses we get. So if we go to this example, let's just walk through this one. So 1 plus 2 times 3, and then this is like this, 8, 4, plus 1. So essentially, we can just keep track of like how many parentheses we have. So here we have 1, here we have 2, here we close 1, so we have 1. Then we have 2, then we have 3, then we close 1, so we have 2, then we have 1, then we have 0. So the most we ever had that were opened at a time was 3. And that's basically all we have to do for this problem. So all we have to do is just keep track of how many parentheses we have and get the max. And that's what we're going to do. So we can code that, pretty easy. So we're gonna have a result, we'll set it equal to 0, and we'll have like a current. We'll set that equal to 0. And we're gonna go through the characters, and the only characters we care about are open and close parentheses, because even if there's nothing in here, that's still depth. So that's what we're gonna do. So we're gonna say for int I equals 0, I is less than s.length. All we care about is the open and close parenthesis. So if s character is equal to an open parenthesis, we will add 1 to our current value. And if it's a closed parenthesis, close. This was actually, yeah, this is fine. Too much coding today, can't tell what open and close parenthesis is. So if it's closed, then we will subtract 1, and we will just maximize the result here. And that's basically all. Like, we don't care about anything other than parentheses, so that's all we need to do. Just we keep track of how many open, how many close, and just get the max depth like that. Then we just return. And yeah, the hardest part is, like I said, reading the problem description where they give you all this stuff that's kind of like not needed. And let's see. Oh, right, this needs to be this. Probably have something else screwed up. All right, let's see. Math. Okay, yeah, definitely been a long day. All right. And there we go. So pretty easy one. So I am curious. I'm not sure in Java. I have to look it up. So if you do like string to character array, if that counts as like space, not exactly sure. So I did it this way. So if the string to character array doesn't do space, then you can use that as well. And then you can like loop through all the characters instead of using an index, because the index doesn't matter. But this way for sure is constant space. So this is going to be O of n time, where n is the length of the string, and O of 1 space, since we just like loop through it. So pretty easy one. Yeah, and there's not much to this one, so that's gonna be all for this one. If you did like this video, please like it and please subscribe to the channel. And I think people ask why I switched to Java. I just kind of got bored of doing problems in Python, because I feel like I was pretty comfortable with it. And I'm still going to do the weekly contest problems in Python. I didn't do them last week because I had a bunch of stuff going on this week, but I'll try to keep that going as well. So those are going to be in Python just because those are like pretty verbose. You know, some of them are like 80 lines of code, a lot tougher than these. But the problems of the day I'll do in Java. So yeah, thanks for watching.